we're going to take a look at simplifying radicals rules. We're going to start with the very basics where we're just simplifying a radical as far down as we possibly can. Then we're going to look at some different things where we multiply, divide, and add or subtract, and how we can do those different things with radicals. To begin with, when we talk about simplifying, we are never going to have any decimals with these. Okay, we just want to simplify the actual radicals down as far as we possibly can. So let's start with a basic one. Let's say we have square root of 45. Okay, and we want to simplify that down. Okay, well, let's talk about what we can do. Think about what 45 is equal to. Whenever you approach one of these and you're trying to simplify down, I would always try to think about what's the biggest perfect square that I know will go into this number. So 45, we know we could break that into 9 times 5. 9, of course, being a perfect square. So now if we think about taking out the perfect square for 9, square root of 9 is 3. We've taken that out, and then we want to leave the 5 inside because we can't take out a square root of 5. So again, think about what we did. We just took that 9, took the square root and brought it outside to get the 3 out front, and then left the 5 inside the square root. So a simplified version of square root of 45 is 3 square roots of 5. Okay, let's take a look at another one. Let's say we have square root of 27. Okay, again, let's think about how we could break this down. We know that 27 is 9 times 3. Okay, again, square root of 9 is 3, and we have another 3 that we're going to have to leave inside because we don't have a square root for that. So square root of 27 can be reduced to 3 square roots of 3. Okay, let's try another one that might be a little bit more difficult. Let's say we have square root of 72. Okay, now, again, this is where knowing perfect squares and knowing a lot of multiplication stuff can really help you out. When I look at this, my first thought is, okay, well, 72 is 36 times 2, right? Square root of 36 is 6, and we have to leave the 2 inside because it's not a perfect square. So we can reduce square root of 72 into being 6 square roots of 2. Now, let's say you didn't see that. Let's say you didn't notice that that's 36 times 2 and you took a longer route. We can still get to the same answer. Let's say you looked at this and said, well, 72, I know that's 9 times 8. Okay, well, square root of 9 is 3, and then that would leave the 8 inside the square root. The problem here is we can break 8 down further, right? Okay, think about 8. 8 is 4 times 2. Okay, we already have a 3 on the outside. Okay, now if we take the square root of 4 out, that would be a 2 on the outside, and we need to leave this other 2 inside. Okay, now take a look at what we have outside. We have a 3 times 2. 3 times 2 gives us 6, and we still have square root of 2. Notice that we get the same thing no matter which way we go. It just takes us a little bit longer if we don't see the biggest perfect square to begin with. Okay, but you can still get to that same answer. Okay, so again, there's no one correct way to do all of these. I will, of course, show you the fastest way, which was that original way with 36 times 2 inside the square root. But there's no set way that you have to do these. Okay, you can look at different ways to set these up and still get to the same answer. Okay, it just might take you a little bit longer depending on which multiples you pick. All right, let's take a look at one more before we start multiplying. Let's say we have square root of 75. Okay, an easy way to look at this one, we know that 75 is 25 times 3. Square root of 25 is 5, and that leaves a 3 inside. So we can reduce square root of 25 to be 5 square roots of 3. Now, again, if you didn't see that, okay, well, let's think about how else we might have looked at this one. Maybe you said, okay, I know 75 is 15 times 5. Okay, now we don't have any perfect squares there, do we? So you would have had to keep going. Well, 15 is 5 times 3, and notice we still have a times 5 here. Now, notice that we have two 5 terms, okay? So if we had if we have two of the same term, we can take out that square root because 5 times 5 obviously would be 25, and square root of 25 would be 5. And then the 3 would be left inside. Either way, we're going to get to the same answer. It just depends on which way you look at it. All right, let's take a look now at multiplying radicals. Let's say we have square root of 18 times square root of 72. We want to simplify down. Anytime I do these problems, I like to try to simplify the individual components first, mainly because I don't want to do 18 times 72, and that's what we would have to do. If we go ahead and multiply what's inside the square roots, we would have to do 18 times 72 and then try to break that down. Instead of doing that, let's break each of these down individually before we do the multiplication. So let's take a look at the first one. 18 we know is 9 times 2, right? Square root of 9 we can bring out would be 3, and that leaves a 2 inside. Okay, so we could rewrite square root of 18 as 3 square roots of 2. Now let's talk about square root of 72. We already did this one. Okay, but oops, I don't need to rewrite that. We already did square root of 72, but let's just have a quick refresher on that. 72 is 36 times 2. 36, of course, is a perfect square. Let's take that out, and that would give us 6 on the outside and 2 on the inside. So now we can rewrite the second part, square root of 72, as 6 square roots of 2. Okay, we want to multiply. Anytime you have radicals that you're multiplying, you want to multiply the outside number times the outside number. So 3 times 6, those are the two outside numbers, would give us 18. Now, inside, you want to multiply as well. So inside the square roots, we have a 2 and a 2. So 2 times 2 gives us 4. Now, if you can break down the square root any further, you want to do that before you finish, which in this case, 4 is a perfect square. So square root of 4 is 2. So the radical is completely gone in this case. And then 18 times 2 gives us 36. Okay, so if you can break that square root down further, you want to make sure you do so before you get your final answer. Let's try another one. Let's say we have square root of 27 times square root of 24. Okay, again, I'm going to break them down to begin with before I start this problem. Square root of 27, we already did this one. Remember, that's 9 times 3. We can take out square root of 9, which is 3, and that leaves 3 inside. So we can say this first one is 3 square roots of 3. All right, now let's take a look at the second one. Square root of 24, we haven't done that one yet. 24, we can say is 4 times 6. Take out the square root of 4, which would be 2, and that leaves the 6 inside. Cannot break that one down anymore because 6 is just 2 times 3. There's no perfect square in there. So the second one is 2 square roots of 6. Now, let's go with what we said earlier. Outside times outside, 3 times 2 gives us 6. Inside times inside, 3 times 6 gives us 18. Now, remember, we want to simplify, simplify the radical if we can. We still are going to have this 6. Let's take a look at that radical. 18, we know, is 9 times 2. Okay, so the 6 is still on the outside. The square root of 9 we can bring outside as 3, and then the 2's got to stay inside. So we have one step left. On the outside, we have 6 times 3, which would be 18. So we have 18 square roots of 2 as our final answer. Okay, again, you want to try to simplify to begin with. That makes it a lot easier. Think about if we had not simplified those, we would have 27 times 24 inside our radical. And again, those are just big numbers we don't want to have to deal with if we can avoid it. If we can go ahead and simplify to begin with, that makes it go a lot faster, and it's a lot easier to see how to simplify down. All right, let's take a look at dividing. Okay, there's two things I kind of want to talk to you guys about. First of all, something that's called rationalizing. Okay, very important when we're dealing with radicals, because if we divide by a radical, we don't want to leave that on the bottom. That's kind of a mathematical no-no. And so say we have something like this, 6 divided by square root of 5. Now, we can't break that down anymore. 6 already just a plain number with no radical. Square root of 5, we can't change that. That's just going to say square root of 5 because it's not a perfect square and doesn't have one in there. So whenever we are left with something like this where we have a square root on the bottom, we have to get it off of the bottom, okay? And to do that, we do something that's called rationalizing. In order to rationalize, we want to get rid of that square root, so we're going to multiply by square root of 5 over square root of 5. Now let's think about why. That's basically multiplying by 1, right? Square root of 5 divided by square root of 5, anything divided by itself is 1. So we're not altering the value of this, we're just making it look more mathematically correct. Now let's take a look at the top. 6 times square root of 5 is just going to stay 6 square roots of 5. We can't break that down any. Now on the bottom, square root of 5 times square root of 5, think about that. That would give us square root of 25. Well, square root of 25 is 5. So that gives us 6 square roots of 5 over 5. And that would be our final answer. That would be as simplified as we could get this one. Okay. Now we might put some of this together. We may start off with something where we have to simplify down, and then we might have to rationalize whenever we see it. Let's try another example. Let's say we have 5 over the square root of 15. Okay, we can't break anything down right now, so let's go ahead and rationalize. Let's multiply it by square root of 15 over square root of 15. Okay, on the top, 5 and square root of 15. On the bottom, square root of 15 times square root of 15. Again, we're trying to get rid of the square root when we do this, so that's just going to give us 15. Now, take a look at your numbers. We notice that we can simplify 5 over 15. They're both divisible by 5. If we divide the top by 5, we have 1. So instead of writing 1 square root of 15, we're just going to write square root of 15. If we divide the bottom by 5, we're going to get 3. So we can reduce 5 square root of 15 over 15 to be square root of 15 over 3. Okay, one more that I want to try with dividing. Let's say we have square root of 72 divided by 3 square roots of 2. Okay, before I would try to do anything with this one, you could go ahead and rationalize if you want to, but for me, whenever I try one of these, I want to, again, simplify down first. Just like we did with multiplying, I always try to simplify down to begin with when I'm dividing, if at all possible. So that square root of 72, we've already done this one a couple times. Remember, we said that's equivalent to 36 times 2 inside the square root, and then 36 is a perfect square. If we take out the square root of 36, which is 6, that leaves a 2 inside. So now I could rewrite this one as 6 square roots of 2 over 3 square roots of 2. Now, your first instinct might be to go ahead and rationalize because you have a square root on the bottom. But in this case, notice that you have the same square root on top as you do on the bottom, don't you? So square root of 2 divided by square root of 2 cancels out and is just 1. So that leaves us with 6 over 3, which we can reduce. 6 divided by 3 gives us 2. And that's our final answer here. All right. Let's try one more where we might have a radical in top and bottom, and we can't simplify anything to begin with, so we have to rationalize. Let's say we have 3 square roots of 2 over square root of 7. Okay, now we can't simplify anything down anymore. Square root of 2 is as simple as it gets. Square root of 7 is as simple as it gets. Cannot do anything else. So we want to rationalize. So let's multiply by square root of 7 over square root of 7. Okay, on the top, you can think of this as like a 1 being outside, right? So 3 times 1 is still just 3. Now let's look at our square roots. Inside the square roots, we have 2 times 7, which is 14. Then on the bottom, Square root of 7 times square root of 7, that gets rid of the square root, and we just have 7. Okay, this is as far as we can go. We cannot simplify down anymore. Some people will say, well, why can't I divide 14 by 7? Notice that the 14 is underneath the square root, so you cannot divide it since the 7 is not under a square root. Okay, so this is our final answer. That's as simple as that one will get. Okay, let's try some adding and subtracting. The big thing about adding and subtracting is that we must have the same square root in order to be able to add and subtract. Think about if you have the same variable. For example, if you have 2x plus 3x, you can combine those to be 5x, right? But if you have 2x plus 3y, you can't combine those because they're two different variables. The same is true for our radicals. So just a quick example, let's say we have 2 square roots of 2 plus 3 square roots of 2 to kind of go along with this, okay? If we have 2 square roots of 2 plus 3 square roots of 2, notice that the square roots are the same. They both have a square root of 2, so we can combine them. 2 plus 3 gives us 5 square roots of 2, just like it gave us 5x when we had 2x plus 3x. Now, if we have different square roots, we cannot combine them. Let's say you have, again, 2 square roots of 2, but this time we have 3 square roots of, pick something up, 5. Okay, notice that these are not the same square root. Okay, they're not the same square root, so we can't combine these. If we had this expression, this is how we would leave it because we can't do anything. We cannot combine. Please be careful about this. This is one of the biggest mistakes that I see. People will combine these when they don't have the same square root. Okay, so let's take a look at some examples of adding and subtracting. We may have to do some simplifying to begin with. Let's say we have square root of 75 plus square root of 3. Now, at first glance, these do not have the same square roots, but we need to try to simplify down to see if we're going to have the same square roots. Take a look at 75. I believe we've already done this one. We know that 75 is 25 times 3. Square root of 25, of course, we can bring that out, is 5, and we leave the 3 inside. So we could rewrite this one as 5 square roots of 3 plus square root of 3. We simplified that square root of 75. So notice if we do that, 5 square roots of 3 plus, think of this again as a 1 square roots of 3. 5 plus 1 gives us 6 square roots of 3. Okay, so your radical is going to stay there when you're adding and subtracting. It's not going to get rid of it like it does sometimes when we are multiplying. All right, let's try one more. Okay, let's say we've got square root of 20 plus square root of 45 minus square root of 5 plus square root of 3. So we got a lot going on here. Let's take a look. 20, let's break that one down. Square root of 20, we know that 20 is 4 times 5. Square root of 4 we could take out and get a 2 and leave the 5 inside. So we could say already that this is equivalent to 2 square roots of 5 plus, now let's take a look at 45. Square root of 45, we've already done this one, but let's think about it. 45 is 9 times 5. So now if we have 9 times 5, square root of 9 is 3 we could take out, leave the 5 inside. So that gives us 3 square roots of 5 for 45. Now, minus square root of 5 plus square root of 3. Those are already as simple as we could get them. We can't break them down further. So let's think about what we can combine. These 3 terms have the same square root. We can combine those. Okay, 2 plus 3 minus 1. So 2 plus 3 minus 1 gives us 4, and we have square root of 5. Okay, now the square root of 3 over here to the right. It is not the same square root, so we just leave it as it is. So our final answer would be 4 square roots of 5 plus square root of 3. Okay, guys, hopefully this has been a good overview. This is probably something that you have seen before, and hopefully this was just a refresher. If not, then you have plenty of practice stuff to go through and make sure you feel confident with this. Please feel free to send me a message if you have any questions.